Welcome to today's webinar, a look at native GPU solvers. We have an action-packed agenda today. We're going to cover a lot of material. Don't worry about writing everything down. This is going to be recorded so that you can watch it at your leisure afterwards for any of the tables and stuff that we show in this webinar. So to start off with, we're going to talk about a little bit about who is TotalCAE. What TotalCAE does is we help clients reduce simulation time by up to 80% without being an IT expert. So a lot of this webinar is about reducing simulation time. If you want to adopt all this high-end technology and have it simple to use, TotalCAE comes in with a cluster or a cloud system in your own environment and then makes it so you can just with a couple points of clicks run all your applications, GPU-enabled application, AI, ML applications, whatever you'd like to run. So everything that happens from the time you push the button till the time you get the results, TotalCAE's managed service will take care of all that. It includes lots of easy-to-use software to make all of these applications super easy to run. Today's topic is about native GPU solving. So why do we want to use a GPU? Well, this is an example of running star CCM plus 322 million cell model. And you can see a 94 core machine has about a 55 elapsed average solver iteration time. And if you just use 8 A100 NVIDIA GPUs or 8 H200, you can't barely see how fast it runs. It runs in, the iteration time is just insane. You can run very, very, very large models that would take thousands of cores on a single machine that has 8 GPUs, for example. And so with the advent of the H200, which has very high memory bandwidth, really unlocked to run some of the largest models without taking a huge footprint in the data center to run. Similarly with Fluent, who also has a native GPU solver, over 24x speed up, running with an 8 H100s over a 512 core cluster. Again, big speed ups, a lot less power, less cooling. And Altair Ultra Fluid X, another native GPU solver, able to scale beautifully on large models on 2, 4, 8 GPUs. Now, GPU computing is not new. It's been around for a while, but what's different is that now that the GPUs are running all natively on the GPU, which we'll talk about in a minute. CPU computing, of course, lots of cores. But they're very, very fast and very good at doing serial work. They're not really as good as parallel computing. So GPUs have thousands and thousands of less powerful cores, but just having so many of them and allowing the algorithms to work in parallel on them means you get a big, huge jump in data crunching. And for mathematical operations, primarily CFD, map really, really good to the GPU. And so that is why you're going to see mainly a focus on CFD solving, particle solving, those kind of things. The equations map really good to the GPU. Other types of engineering solvers that aren't maybe don't always map so well, so you won't see that as a native GPU because often those equations aren't parallelized in a way that map really well. And the amount of power that's in a GPU today has been growing by leaps and bounds. So on this diagram here, an NVIDIA A100, it's end of life, can't really buy it anymore, it exists on the cloud. That old technology is the same as the same teraflops, double precision teraflops, as a highest end AMD Genoa X server. And you can see now as the time goes on from right to left, at the AMD, then the NVIDIA H100, H200, the latest AMD Instinct, and then Blackwell that just came out, up to 100 teraflops. That is just in a short period of time span here, we've already went 10 times more double precision teraflops than we had just a little while ago. And so, GPUs are a little bit hard to get. The lead times are a little bit longer. You're looking 6 to 8 weeks to buy it, and there's a competition on the cloud to rent it because of the large language model, AI training craze. You can see just on the market, Meta, has 350,000 GPUs. X, Twitter, Tesla, hundreds of thousands. So there's lots of GPUs being bought by the bucket load. And so because of many of these kinds of advances that we're seeing here across other types of codes, today's focus is going to be mainly on CFD, CA applications, not so much in AI, but it's got a wide range of applications. So the main difference of this webinar from past GPU webinars is that native GPU solvers do run everything in the GPU. The CFD, like I mentioned, is native to it, but the problem has to fit into the GPU memory. So different kinds of GPUs, as we'll see, have different amounts of memory. And if your problem doesn't fit completely in the memory, you can add more cards to get it in memory. But the problem can't use your native computer's memory. You could have 100 terabytes of computer memory and still the problem won't solve on the GPU because it runs 100% in that GPU, on the GPU memory. There's a lot of GPU native codes now: Siemens Star C++, Fluent, Rocky, UltraFluidX, ParticleWorks, Fun3D, Charles. There's just a whole bunch. And so I think all the major CFD solvers will eventually have a GPU native version of them, just because of the just tremendous speed improvements that you can see through a GPU. Now, non-native GPU solvers, which we've had exist for a long time, used to do some of the CPU crunching on the CPU, transfer the data to the GPU, run some there, and move it back and forth. And you're going to see diminishing returns on those kinds of GPU solvers, and that's primarily in the non-CFD realm, just because there is overhead of going from CPU to GPU and GPU to CPU, and it's not quite the impressive gains that we see when you have a native GPU and the equations map for that. So, and often a question we get is well, what GPU should I pick? Well, for CFD, a high-end card with lots of memory bandwidth is very important. CFD is typically memory bandwidth bound, whether it's CPU or GPU. And you need enough memory to fit your model, like we just discussed. And so on-prem, the decision's kind of easy. Most all NVIDIA cards are end of life. We got the L40S, the H100, H200, some other lower-end cards. But really, the H100, H200 are the sweet spot. Just incredible cards for CFD, as we'll see. And that decision is a little bit easier, for if you don't watch the rest of this webinar, that's what you can know. Now, you can't buy the H200 really in single GPU flavors. It's kind of an 8-way card, as we'll see, but as you will go through kind of the criteria. So the H200 is really great. It has a lot of memory bandwidth, so you can run some of the largest models on an 8-way machine. You have to, like I mentioned, fit all into memory. Now, there's different kinds of memory. When you look on most of the high-end cards, you're going to see they have high bandwidth HBM memory. Things like an NVIDIA graphics card, you're going to see has DDR6, and that isn't got quite the speed of the HBM memory, and that's why all memory isn't created equal based on the graphics card. Not all cards support what's called FP64, which is basically a fancy way to say double precision. Now, you don't need a double precision card to do double precision. Those lower end cards can still work. Even you could do double precision on a card that doesn't have it. They just run slower. Now, realize double precision, of course, needs more memory bandwidth. So that's why the high end cards, that have double precision have high memory bandwidth. And you still, if you have a GPU, can't get rid of the CPUs. Typically, most GPU configurations will have around 32 cores. In those, sometimes meshing is done on the CPU. The CPU still is the brains of the computer and has to handle other tasks. So you aren't going to go with a one CPU box and then, funnel all your money into the GPU. You're still going to need some cores on the machines that you're selecting. So on the GPU memory, you're going to want to pick a card that has enough memory to run your model, or you're going to need to run multiple of those cards. Most workstations might have a slot for one card. Servers can go up to 8-way, but those are specialized. Some of the lower end servers can do 1 or 2 GPUs per box, or 4. So we kind of printed out here the number on the left axis. Here is the amount of GPU memory per card. You can see on the very low end, you might only have 48 gigs. On the highest end, Blackwell, almost 400 gigs of memory. And so, that's going to run the largest models you can. Of course, that's sold out for a year at the time of this writing, but certainly the H200 is widely available, still has a lot of memory per card. So how much memory, do you think you might need? Every application has a different rule of thumb. I just picked 2 here that were kind of easy to have. One is, Fluent, about 1 million cells, for single precision. If you need double precision, it's about double that. And so that could give you a feeling for hey, if I have a 24 million cell model, I might need a card that has around 24 gigs of memory on it. And same with Siemens Star CCM Plus. You could run about a 60 million trim cells mixed precision on an 80 gig card, like AA100 or better. So it gives you a feel like, hey, if my GPU that I have only has like 6 gigs of memory, you're not going to be able to run that large a model, but your models may be smaller than that. So it just really depends on the model size you're trying to solve to match the GPU to it. Now, the memory bandwidth, like I mentioned, is pretty dependent on the kind of card. Basically, the high-end cars, H100 and better, have really good memory bandwidth, and that's just going to help speed up and your models and be able to run even those larger models if you want to run in the 300 million cell model. Now here's a little table that we made of the most popular cards. For on-prem, you can only get basically H100, H200, A30, A40, L40S. The A100 you can't really get anymore, but you can still get that on the cloud, and even older cards like the V100 and other older generation cards are available. But I just wanted to highlight just the incredible jump in not only memory, teraflops, bandwidth, just in the last generation from the H200 to the NVIDIA Blackwell, just incredible jumps in performance. And so I anticipate this continue. And so, yeah, a lot of exciting innovation in terms of performance. And really, H200 and higher really just started unlocking us be able to run giant models really efficiently in one box with Star, Fluent, UltraFluid X, and others. So a lot of times people want to have an idea of like, well, what are the costs of these things? And so I tried to make a graph here to show you, if you pick some of the lower end GPUs, like an L40S, and pitted it against like the highest performance CPU cores, what would it be? So if you had about $50,000, you could get the latest generation Intel, latest generation AMD. But you can see just a one node 4 L40S, which is a low end card, is about the same price. And you're getting about double the performance here. So for double to triple, the performance of these other ones for the same amount of money. But if you had $50,000, you actually wouldn't buy the low end 4 L40S. Possibly, you'd probably just get a higher end card, which we'll see in a second. Because this is kind of apples and apples, $48,000 for a GPU node versus a 400 core cluster. A single H100 is about $50,000 for one card in the server. You get a $50,000 server. That can go up to $1,500. Same performance as a 1,500 core 8 node box. So for a $50,000 budget, you get a H100, that would be like you getting a 1,500 core cluster. A lot less power, a lot easier to put in the data center for about the same amount of money, just easier and simpler to manage. So these boxes this is kind of what an 8-way box looks like. You can have an 8-way H200, it's about $250,000. That is the same as performance, as a 4,000 core system of the latest generation, 20 nodes. So still, on the high end, you can replace a lot of equipment with just a single box course and for similar price point, slightly cheaper. Now on the cloud, GPU computing, all of these GPUs are there. Those you could rent by the hour sometimes you can rent by the day. So we're going to go a little bit about how do you select a GPU if you're a cloud only or wanting just to try them on the cloud, which is a very low barrier entry. You can try it without spending $50,000 or $250,000 to see how it works out for you before you to make any kind of investment like that. On Azure, they have all of the latest high-end cards. They also have some of the older generation cards, and this is kind of the list pricing and some just information. If you're like, hey, I want to run an H200, what is the Azure name? This will save you some time looking it up. AWS also has something very similar. They have a large variety of different cards available to you. Some are on demand and some are not on demand, and they use a thing called a capacity block, which we'll talk about here briefly. But you have all sizes. You could get less than 8 per node. I'm just showing some of the high-end cards here. So here's kind of a graph of the pricing if you wanted to run an 8-way card and run some giant models. On the right, you're going to see on-demand available. So P316, P3DN, some older, the V100s, as well as the latest L40S. Those cards can be run 8-way on demand. So that means no commitment, just push the button. You could rent it for an hour, no problem. The ones to the left, which are the high ends, the A100s, H100, H200, need what's called a capacity block, which we're going to talk about here in a little bit. But you basically rent them for a day minimum in advance, making a reservation. And so you don't really rent them by the hour. It's more by the day, multiple days. And a capacity block is like a advanced reservation at a hotel that you've prepaid. So you go and you look on the, which we'll show a screenshot here in a second. You go and look in the future and you say, I want this kind of GPU, and it tells you when you can have it. You pay for it right then, at least one day. And then when that time comes in the future, then you pay for it whether you use it or not. The nice thing about scheduling is you don't get no capacity available. You try to turn it on and there's just none available because it's so hugely popular right now to use these things. The con might be that sometimes the capacity block might not come for a day, 2 days, could be longer, but 1 or 2 days. So maybe you need the answer before then, and it's not as convenient to, maybe you only want to run 2 hours and you don't really want to pay for an entire day. Those are some of the cons of the capacity block. But to request it is quite easy. You just go into the console here, for example, and you pick the machine, and then you click find. When's the earliest day I want to start? You do find. It tries to find it for you. I put 1 day, which is the minimum amount here, and then it said, okay, great. I found one. In this case, I just had to wait 1 day. Tomorrow I can get you this awesome H200, 8 of them, $1,000. Pay my $1,000 today. And then tomorrow it becomes available to me and I can run for up to the time limit of 24 hours for that $1,000. And so that's why the cloud price is a little tricky. So if you compare like that on-demand for L40S, and I just run a 50 million model from Fluent here, I can get 260 MIUPSs, that's million instruction updates per second. But you see the H200, it just blows it out of the water, like 1962. I mean, that is just a phenomenal jump up. And the hourly rate is only 4 times that. But I do have to rent it for 24 hours minimum. So if I just ran one job, maybe the job cost would be much higher on the other machine because I have to rent it for 24 hours versus maybe I only run for an hour. So $1,000 versus $10. But if I'm keeping it busy a lot, then it's definitely better to use the H200 because I'm getting just phenomenal throughput on that, and I could put a lot more work done in that same 24 hours than I could ever get done on an L40S. So the strategy is a little bit more complicated between the high and the low end cards, but it's definitely something that you could benchmark your model and determine what is the best strategy for me based on your workflow and so on. Now, how do you run on the GPU? Well, with TotalCAE, we have a portal and a command line, some other ways to run. On the portal, you just add a flag. So like for Fluent, you just add minus GPU equals 4, the extra arguments, that's it. Star is also extremely easy. It's a little confusing, but the number of processors you typically use are 1 or 2 cores per GPU. So you might say like to run on 2 GPUs, you'd have NP2 and then GPU2 auto :2. UltraFluid X, you just have to pass the number of GPUs plus 1. So if you want to use 2 GPUs, you put MPI run minus MP3. This is if you're doing the command line. And then in Particle Works, you just have to pass minus G to how many options you want. So pretty simple. Using the Fluent GUI, there's also GUI ways if you're not using like a batch system. There you just have to have an enterprise license. So you just pick enterprise in the Fluent launcher and click native GPU solver. It'll tell you how many licenses you'll need and what kind of GPU you're running on. Pretty straightforward to run through the Fluent GUI. Now, how do you know the GPU is being used? A couple different ways. There's a tool that comes with NVIDIA drivers called NVIDIA SMI. And when you run that, you're going to see at the bottom, it'll show each of your GPUs. It's going to show that, there's a process, like in this case, they say Fluent is running on the GPU. And it shows me each GPU and that Fluent's running there. And I can kind of see how much memory I'm using per each of the GPUs on this L40S. Now, oftentimes the application output itself is going to tell you that, like in the upper right here, it's showing me, hey, Fluent's running on these different GPUs and giving me a lot of great stats about what it sees. TotalCAE also has an analyzer that gives you like the GPU usage. So if you want to go back in time when your job's not running, like over the weekend, you can go and see a graph of all the GPUs and how they're used, just in case it ran out of memory or you weren't sure if it used the GPU or not. You'd be able to go back and tell. Now for GPU adoption planning, there's really three key things we want to do if you're thinking about doing a GPU. One is the model size. The next is power and cooling and data center issues. And the third is the licensing. So we're just going to go through those quickly. We talked a lot about the GPU memory. There's also, is your GPU compatible? Some of the native GPU solvers aren't 100% compatible with the CPU equivalencies. They're definitely narrowing the gap. The vendors have really good documentation on the differences between the CPU, the GPU solver. And that changes every single release. So you want to make sure that any kind of things you're going to be doing would be compatible. If you're unsure, the vendor could help you, or could certainly just benchmark it on a cloud system for very low cost and just see what happens. Does it work? Then you need to make sure that the model you're picking fits into the GPU memory. If you pick something modern like a H200, it's almost certainly going to fit, but it is good to kind of estimate the model size and what kind of GPUs you're going to use. Here's some of the previous metrics, kind of rules of thumb on model size and how much memory you need on a couple different popular CFD apps. And like I mentioned, if you no worries, if you can't fit one into one GPU, you could always add multiple GPUs. Now, if you decide you want to get an 8-way H200, now there's other considerations outside of just getting it. One is that they do need a lot of power. This particular server needs about 6 kilowatts, which is a L630 circuit. That's not uncommon in a data center, pretty common actually. But you need to make sure that you have a rack to put it in. It's a couple 250 pounds. Needs 19,000 BTU of cooling. So it's not going to be something you put in a closet, but any modern data center will be able to put one or two of these into a rack, and you'd be able to power it with even just most standard configurations. But still, it's good to plan with your data center people, and the price of those ranges anywhere from $250,000, $300,000 at this time. These are very high-end cards. But while that price might sound expensive, when you see how much compute power it actually replaces, like regular compute nodes, it actually is typically a cost save, and it uses less power than CPU nodes. Then we're going to talk a little bit about licensing. Almost every vendor has a different way that they do the licensing. Siemens, Star CCM Plus, you need a Power Session Plus enabled that basically lets you run unlimited GPU or CPU, similar to like a power license, but this one's for GPUs. Specifically enables unlimited GPU. Ansys's GPU pricing is a little bit more tricky. It is based on the number and the powerfulness of your GPU, which we'll talk about. And Altair UltraFluidX uses their Altair units based on the number of GPUs used. So I'll talk a little bit about Ansys if you're an Ansys shop. They're going to have this thing called streaming multiprocessors, SMs. So each GPU has a published SMs in the datasheet you can find. This is a little table that Ansys puts together, which is nice, that shows you the number of SMs. You get 40 SMs for free with a CFD Enterprise license. And basically, the more powerful GPU, the more SMs you're going to need, and therefore the more HPC packs that are required. Since that table on that website hasn't been updated for the H200, I thought I'd show a little exercise here. Look up on the data sheet, and H200 has 132 SMs. So that 8-way GPU box is going to take 1056 SMs minus the 40 I get for free, and that would require 5 HPC packs. So you can just look at a little table that Ansys provides and say, okay, I'm at 1,000 something, and that is going to be 5 packs. Now, that's if you run all 8 GPUs. UltraFluidX is just how many GPUs. One takes 50 Altair units. You run an 8-way, it takes 200. But every vendor has a different way to do licensing, so just make sure you have enough licensing and you consider it in your budget, because it's not just buying the hardware, but you need to make sure you got the licensing to drive it. Now, we talked a lot about NVIDIA GPUs, but Intel and AMD also make GPUs. We don't really see a lot of Intel at this time, but AMD is now being supported by multiple vendors. Star CCM Plus and Ansys Fluent now support it. They have some benchmarks here to show it's a similar performance to the older NVIDIA A100. and it is definitely cheaper than buying like an H200, but it is less performant than such a H200 or Blackwell. But there is support forthcoming. Competition's good, so just be aware if you do have an AMD GPU by chance, you can definitely use that on many applications now. It's just not just NVIDIA GPUs that you need to use. Now, if you go to multiple GPUs, one thing to realize is that there is a thing that you may want to have called NVLink. You can think of it as how GPUs hook together with a fast network inside the box. So lower-end cards don't have NVLink, like an L40S, but a high-end card, they'll usually have an NVLink connecting all the cards inside, and then you run a little program called the Fabric Manager, which helps almost like as a router to route the data between the machines. Now, when you run Star CCM Plus on an 8-way box, you'll see it has a message about it starting it up in the background on your behalf. But some other applications, you may need to start that Fabric Manager, or your systems administrator may have it always running on the box before you run. If you have one GPU, you don't need an NVLink. There's no network that's needed if it's just one side, one card. And AMD has something similar. It's called Infinity Fabric, same kind of idea. Now, if you want to monitor if the fabric's running, there's a little command here just throwing it in, so you can just make sure that the NVLink is going up. Now, if you don't have NVLink, does that mean an 8-way box won't work? Nope, it'll run. It may run slightly slower. It may get the same. It's not absolutely required to have NVLink, but it does give the most performance when you have these high-end 8-way machines. Some couple of GPU performance tips. One thing is there's a daemon called NVIDIA Persistence D. You may want to have this running in the background. It kind of helps speed up the GPU run by not having to tear up and tear down the GPU during runs. One thing that's nice for debugging, if you set NVIDIA exclusive access, then that means only one thing at a time can be running on that box. It's helpful if you get rogue processes running in the background and might be consuming some GPU and stealing it from your run. It's kind of nice to have that, as then you have exclusive access and are getting the most performance out of all of those. And most of the time, you're just running one user per GPU box. If you're a Fluent user, you could try the minus GPU remap. It seems up to 20% speed ups on certain applications for that. And on some GPUs, you can overclock them. They have different clock rates, just like a CPU might, and there's some fixed clocks that you can do, turn off power saving, that kind of thing. One interesting thing as the time is writing is GPU drivers are now being exploited by hackers. There's a lot of interest in the power of those. So there's 8 high severity vulnerabilities for Windows and Linux just released as the time of this writing. So just make sure your system administrator is adding GPUs to their update patching policy, just to make sure that you're not getting hit with any of the new GPUs as a security risk. Now, one of the biggest questions we typically get when we're talking about, and people see like, $50,000 for a machine, for these high-end machines, like, why can't I just use my workstation's GPU? And you totally can. The main limit of the workstation GPU is it's typically not a huge amount of memory. It also doesn't usually have the fastest memory bandwidth type of memory. It has a DDR6, and so you're going to be limited in the size of the model. But if you have smaller models, you can 100% use that GPU if it'll fit in there. So the latest Quadro cards, they could run about a 20 million cell Fluent model with a couple HPC packs. And here is some other kind of information about comparing an RTX A4000, with a 56 core workstation. So that's a little bit of an older card, but still could run this 7 million model benchmark, still twice as fast as a CPU. So you certainly can use your GPU in a workstation. Once you hit the workstation limit, just kind of like when you hit the limit of how long you're willing to wait for a CPU, that's when you're going to want to go a cluster or a small GPU cluster that can schedule those jobs and really get the throughput through. Now, if you're interested in getting more information, of course, speaking with your CAE solver vendor, we'll always have great resources. We do have a reducing simulation time ebook that has a lot of these things that are in this webinar in an ebook format and even more detail. And then we have application-specific guides on different apps and how they relate to GPUs. Same for the cloud computing books. Just email us if you're interested in any of these content. We also do have a GPU benchmark program. So if you're running extremely large models, you want to see, you're running on 500 to 1,000 cores, and you just want to see, can I use a GPU system instead? Reach out to us about the program requirements, and we can help you make sure you can see the kind of benefits on your own models that we show here on standard benchmarks. I just want to thank you for attending today. Keep posted for future webinars, and we look forward to seeing you on the next event.